This robot can plant, monitor, and harvest fresh produce, learning directly from human touch.
If I want the robot to move like front, I can just push the robot and then the arm will push forward. If you want to rotate, this is the rotation. So you can see the robot is moving.
The bot's being trained using these haptic gloves, made from scratch by researcher Paul Hung-Hon Chang at EPFL. As he controls the arms via teleoperation, it translates his touch into data. Then, using AI, the robot learns how to perform the movements all on its own.
So we can train the robot, kind of like transfer our skill to the robot. And then later on, you can have more like autonomous tasks in the farm. And then all you need to do is just monitoring, which makes the life easier.
The team's goal is to automate indoor farming, making it more efficient.
The robot is being trained to detect the seedling, so it recognizes it. And when it's done so, it can just go and plant it to the desired height.
Research engineer Jermaine Meyer made the arms and dexterous grippers, each specially designed for a specific task.
This one is made for planting, so with a conical shape that allows to insert into those foam pads. And we have one here, which is made for cutting. And so this way we can take care of each stage of the plant growth.
Operating on a rail, the team hope they can scale up the project, one day having a fleet working together autonomously.
We can really have new ways of how we could deploy our robots for new tasks and trying to really close the full growing cycle with robots.
Their system was inspired by this raspberry harvesting robot that we featured back in 2022 when we visited Assistant Professor Josie Hughes and her Create Lab.
So in terms of what drew me to using robots to address problems with food, it's a really interesting problem for robotics.
Now we're back to see what the next generation have installed.
Working on assembling a new robot.
It's got bendable legs with rigid structures and then...
Here, they're developing new forms of bio-inspired intelligent robots for agriculture to food systems and just about everything in between.
From farm to fork, I think there's many different places where robots can make an impact. So I think trying to really identify use cases where robots can do things that maybe humans can't without taking away that very important human contact and the human ability to be creative and imaginative is really important.
One of the more unusual robots under development here is the GOAT, short for Good on All Terrains. Tested in the Swiss Alps, the shape-shifting rover is built to move through challenging landscapes. It uses motors to morph and adapt to its surroundings, enabling it to crawl, roll, and now even fly.
We started the project seeing that many field robots that exist are very heavy. So we try to make a very lightweight robot that we can put on our backpack and that then can go to places where humans cannot go.
The skeletal frame is made out of fiberglass, the same material as tent poles.
So you can bend them a lot and they are very elastic and they just spring back into shape.
And it could be a game changer for the agriculture industry.
Now we are good to go. Okay.
Today, researcher Max Paulsen is testing the GOAT at a nearby vineyard.
I'm going to try to drive through the vines to do some inspection.
Where he says it can be used to monitor crop health and the environment.
We have quite a lot of wine fields on very steep hills, and one problem is that we barely have any machines that can operate on these inclinations. With this robot that we made that can actually go down slopes very efficiently and drive on a lot of challenging terrain.
The next step is to make the remote-controlled rover fully autonomous, unlocking new possibilities.
We hope to make a contribution to creating the next generation of agricultural machines.
It's a goal many back in the lab are chasing for their own projects, ensuring smarter, more efficient farms for the future.
Robots!